So this problem asks us to plot a specific polar curve, two of them in fact, r1 equals cosine of 2 theta, r2 equals 1. And we need to find the area outside the graph of r1, but inside the graph of r2. So let's try to make these polar plots. R2 is very easy. Its polar expression is just r2 equals 1, so it's all the points that have radius 1. Try again. So it'll be a circle of radius 1. Now what's more complicated is drawing the graph of r1 equals cosine of 2 theta. So what I would recommend you do is draw this in draw the graph of cosine of 2 theta in just a normal coordinate plane if they were x and y. So I know that cosine starts at 1, oscillates, and if it's 2 pi, it will oscillate twice as it gets from 0 to 2 pi. So we can, that's not right. Okay, so we're here. So from 1 to 0, 0 to -1, -1 to 1, and then pi, those occur at increments of pi over 4. So by the time we go all the way halfway around the circle from 0 to pi, our cosine will have oscillated 1 full time, and it will oscillate 1 other full time as we go around the bottom of the circle. So in polar, we've got the cosine starts at 1, and when we get to pi over 4, right here, the cosine should be 0. So we'll do this. That's kind of what it looks like. Then from pi over 4 to pi over 2, our cosine is negative. So that means if we have a negative radius, we'll actually be drawing a portion down here. And then it continues back upward and to here finally. So that's from 0 to pi. If we do the other half, it's going to just repeat the same kind of pattern. Get this kind of flower type thing inside a circle. And what we want is the area that is outside this red graph, but inside the blue graph, as I'm shading here. And what I would recommend doing, instead of trying to integrate the whole thing, if we integrate from 0 to pi over 4, that would be 1/8 of the area, because we'd have 1 here, 2 here, 3, 4, each of these being the same size by symmetry. Obviously not true according to my drawing, but the symmetry is there. So what I want to do is just take one of those 8 and integrate it. So the area will be the integral from 0 to pi over 4 of 1/2 times the upper function squared minus the lower function squared. And it'll be 8 times that, because we've got 8 of these little portions. Okay, so this will be 4 if we pull the 1/2 out front. Inside here, I've got 1 minus cosine squared, which I can replace with minus 1/2 and minus cosine of 4 theta over 2, which makes this doable. So if I integrate, I get 4 times 1 minus 1/2 is 1/2, so I'll say 1/2 theta With the cosine, I'll have to divide by 4 when I integrate, so I'll get sine of 4 theta over 8. Need to plug in pi over 4 and 0. So this will be pi over 8 minus sine of pi is 0. When I plug in zeros, I get these. So I get this. Altogether, it is pi over 2.